David, why are wet beds such a major track maintenance headache for Railtrack?
Wet beds are a major contributor to poor performance and indeed to reduced asset life. They also contribute significantly to poor track geometry and therefore to the ride that our customers on the trains actually feel.
But can't this work only be carried out under green zone conditions?
Yes, it's preferable to do the work under green zone conditions, but it's perfectly acceptable to carry out the work while trains are running at line speed, provided appropriate safety protection arrangements are put in place.
And isn't this video rather out of date to be shown in the 21st century?
It was made some years ago, but the principles of the repair work that are shown on the video haven't changed. What is shown is still best practice, and if the work is carried out in this way, it will ensure a long-lasting repair.
The following video production is the first in a new programme of training films which the Regional Civil Engineer of the London Midland region is producing. The aim is to enable staff to be updated in practical methods of carrying out their work, to ensure that jobs are completed correctly first time. This will lead to increased reliability and reduced maintenance costs for the railway business.
Down fast!
These pictures show the problems of slurried track when allowed to reach an advanced stage. These pictures show the result, the derailment of a train. In this program, we're going to look at the problems of slurry spots and the techniques for dealing with them, carrying out track repair, and making it safe for rail traffic to use. The slurry spots themselves are easy to identify. They show as a cement-like substance on the sleepers and on the top of the ballast. During this program, we shall see a gang demonstrate the correct methods and equipment for carrying out the manual repair of slurried track. Before we go out on location and watch the gang tackle the problem, let's look at the basic techniques with animated graphics. In this instance, the slurry problems lie between sleepers 1 and 4. Seen from above in plan view, the areas of ballast affected by the slurry, which will have to be replaced by fresh ballast, are shown in brown. Viewed from the side in profile, the picture looks like this. The first area to be tackled lies between sleepers 2 and 3, which is dug out to just below bottom of sleeper level. The object of removing this ballast first will become clear as the work progresses. Now the ballast is dug out between sleepers 1 and 2, and a trench should be dug to a depth decided by the track chargeman. Later on in the programme, we shall consider the factors that influence the depth of this trench. The trench between sleepers 1 and 2 is now filled with clean ballast to bottom of sleeper level. This ballast must be consolidated in layers to minimize settlement of the ballast under vibration and provide maximum stability for the track. Sleeper number 2 can now be levered or barred across onto the clean ballast, revealing the slurried section and stool on which it previously rested. This entire slurried section can now be dug out and replaced with fresh ballast to complete the repair up to sleeper number 3. Once this task is completed, sleeper number 2 is levered back into its original position, and the process can be repeated between sleepers number 3 and number 4. Tackling the problems of slurried track demands a highly trained team in which every member understands the requirements and the methods of dealing with the problem. The workday begins with a briefing by the track chargeman, who describes the job to be done and reminds the gang of the safety procedures which must be followed in this kind of track work situation. The next stage is to unload the equipment for the day's work. Using the right tools for the job is an important factor in dealing with slurry spots, and in this program we shall show the tools in a working situation and the correct way to use them. A proper kit will consist of 2 power tools, in this case made by Kango. Like domestic power tools, they have a variety of attachments, and it's important to use the right attachment every time if you're going to do a quality job. These attachments, for example, are for consolidating the fresh ballast, which is vital for track stability and safety. There can be no compromise on safety. Track maintenance requires men to work on lines which are carrying traffic, and in this instance, trains pass at up to 110 miles per hour.
We stop there, lads. Before we go down on site, I'll tell you the direction of the trains. The nearest one is the down fast, then the up fast, then the down slow, and the furthest one away is the up slow. Now we walk along the cess and face all traffic.
Up fast!
Right, lads, these are the slurry spots we're going to work on today. Position the lookout. The one on the right is up on the Pee-wee, and he's going to call you out for the down fast and the down slow. With the checkered flags, and they're going to call you out for the up fast and the up slow. When you're blown out, you will stand in the cess, the place of safety.
The lookout is equipped with portable warning equipment known as a Pee-wee to give the gang an audible warning.
Down fast!
And a control with start-stop buttons to shut down the generator which provides power to the tools. The gang know they will have a minimum of 25 seconds in which to make the track secure and take up a safe position at the side of the track. The affected area of this length of track has been defined as these 4 sleepers. The problem can be seen on the surface of the sleepers and the ballast. It will extend below the sleeper and down into the ballast. On modern track, the slurry is a thick paste which is mainly formed from a concrete powder and water. The powder is generally produced by a grinding action between the base of the concrete sleeper and the stone ballast, but it can be added to by wind deposits from local quarrying or manufacturing processes and spillage from passing wagons, such as coal dust. Tamping machines also aggravate this problem by crushing the ballast when consolidating the track. The slurry may remain as a thick paste or, during hot weather, bake rock hard. In both cases, it forms a barrier which prevents the drainage of rainwater, and the problem begins to accelerate. It's important to try to tackle the problem at the 2 or 3 sleeper stage, rather than allow the slurry to extend further and the track to become unstable. If it extends to 4 sleeper bays, the affected area is the same length as a short wagon wheelbase, and the risk of derailment is increased accordingly. As the firm bed of ballast is replaced by the soft slurry, the sleepers are pumped by the passing trains, and this pumping action produces more slurry and reduces the stability. As we saw at the beginning of the program, the solution to the problem lies in removing all the old ballast containing the slurry and replacing it with new ballast, providing a firm support for the sleepers and rails and giving effective drainage. However, this operation must be carried out without interruption to the traffic flow in terms of imposing speed restrictions or taking possession of the line.
Down fast.
Carrying out the manual repair of slurried track while it is being used by trains requires the strict application of safety procedures. In this program, we shall see how such work can be carried out without danger to traffic or personnel on a fast line with speeds of 110 miles per hour. Before work on slurried track repair can be carried out, the temperature of the track must be checked to ensure that it is within the permitted work range. Work of this nature must not be carried out above 32 degrees centigrade, that is 90 degrees Fahrenheit, because the track can snake or distort and lose lateral stability. Equally, it is not permitted to work on the track below freezing, because the ballast becomes solid. Once the length of track to be repaired has been identified, it is important to make sure that it is given the maximum support before digging out begins. This is done by shovel packing the sleepers throughout the area of work. The recommended procedure, as we saw earlier, is to first dig out the ballast containing the slurry between sleepers 2 and 3 to just below bottom of sleeper level. Then the ballast between sleepers 1 and 2 can be dug out to the full depth. This is done most effectively by using a Kango hammer fitted with a spade end, which is driven by a generator. The generator is located at the side of the track in a safe position and as far away as possible from the working site to reduce the noise level. The slurried ballast is shovelled into baskets and carried to the side of the track, well away from the shoulder, in order not to interfere with track drainage. Dumping the slurried ballast on or near the shoulder can defeat the whole purpose of slurry spot repair. The depth of trench necessary to carry out a proper repair will vary according to the class of line and is dependent upon ballast conditions on individual sites. It should be a minimum of 225 millimeters or 9 inches below bottom of sleeper level. These measurements should be taken at the sleeper ends. This depth must be decided by the track chargeman. Whatever the depth, with the methods outlined in this program, it is entirely safe for traffic to use the line at every stage of the operation. The trench must slope from the 6-foot to the cess, or the nearest drain, with a minimum of 3 inches crossfall, that is 77 millimeters. This crossfall is important to ensure drainage. The difference in level should be measured with a rule from underside sleeper to the bottom of the trench. In taking these measurements, it is important to bear in mind the cant or required difference in levels of the two rails, which should be checked with a cross-level gauge. Once the trench has been fully prepared, the new ballast should be spread in thin layers of about 3 or 4 inches, with each layer compacted before the next one is added. This ensures good consolidation. This compacting operation is again carried out with Kango tools, using a rectangular compacting plate on the end, in place of the spade we saw earlier. Wherever possible, spare ballast should be reused from areas of the track surrounding the worksite. This can then be moved easily to the repair point using a permaskate. Compacting must be done to a pattern of 375 millimeters or 15 inches either side of the rails. The center of the track must not be compacted. because if it is consolidated into a high, hard spot, the pressure of the trains on the rails on either side could bend and crack the sleeper. The new ballast should only be brought up to the level of the underside of the sleeper in order that the second sleeper can be moved sideways onto the new ballast without difficulty. It should be tamped down in the centre to enable this to be done easily, but as we've already pointed out, it must not be consolidated in the centre. Now the sleeper can be moved to its temporary position. The pandrel clips are removed with pan pullers. They should always be replaced with new ones. The nylon inserts are then removed with the aid of a pan setter. Again, these nylons should be replaced as a matter of routine. Hydraulic track lifting jacks are then positioned under each rail, and the rail is lifted slightly to allow the rail seating pads positioned between the rail and the sleeper to be removed with a hand scraper. These pads must be replaced with new pads when the sleeper is in its final position, because if the pad depth is reduced, the tension in the clip is reduced, and this allows chatter when the trains pass over that point. This, in turn, causes deterioration in the fastenings. Using the pan puller and the pan setter, the clip should be replaced temporarily, but without the nylon insulators and the pads. The rails are then jacked up and using slewing bars, the sleeper is moved sideways onto the new ballast. Once the sleeper has been moved from its original position, the stool on which it has been resting is revealed, showing a fatty-looking layer of slurry. The sleeper is tightened up on its new temporary bed, and the bay between sleepers 2 and 3, including the stool, can be excavated. This should now be taken down to the depth of the original trench between sleepers 1 and 2. When this bay is dug out, the crossfall we referred to earlier must be maintained. The cant we referred to earlier must of course be preserved. This is the difference in the levels of the rails. A gang might dig out and reballast up to 6 sleepers in a day, and if there were uneven settlement under one rail, it could derail a train very easily. Once the ballast has been brought up to the level of the underside of the sleeper, sleeper number 2 can be moved back to its old position as indicated by a cross on the rail. As with the use of all tools, the body should be properly braced when using slewing bars for this task.
Together. Hey. Did you pull it your... Right, okay.
The worn-out pad on the right is replaced with a new pad. The nylon insulator too is replaced. And the pandrel clip, which is tightened up with the pan puller. There is always settlement under new ballast, and it's important to follow up with cango packing of the sleepers as necessary. As the track chargeman shows here, the cango tool should be used at a low angle in order to effectively pack the ballast under the sleeper. The 6-foot end and sesh shoulder end are opened out and reballasted a short length of track at a time down to the level of the dug section in the bay. This ensures that all the slurry and choked ballast is removed and that proper drainage can be restored. It is important to note that we emphasize the end should only be dug out a short length of track at a time. This is particularly critical in hot weather to avoid upsetting the lateral stability of the track due to its being unrestrained. It is also important that the ends should be restored to their correct shoulder profiles. The fresh ballast is replaced at the sleeper ends and compacted in layers to restore stability. As we said at the beginning of the program, the process is now repeated between sleepers 3 and 4, and further slurry spots on the line are dealt with in the same way. Once the section is completed, the track must be given a general repair, through from the high spots either side of the finished slurry track repair. With the slurry spots removed and new ballast supporting the track, the gang can feel a sense of pride and achievement in a job well done, improving the safety and quality of the business and using their skill and training to maintain that business without interruption on a very busy line.